The statement of the question is describe briefly the arrangement and movement of the particles present in a solid, a liquid, and a gas. So concentrate yourself. Here is the answer. Solid. Strong forces of the attraction hold the particles closely together in a regular lattice. So the shape of the solid is regular. The particles can only vibrate in fixed positions. Okay, now we are going to read the liquid. The particles are further apart with weaker forces of the attraction between them. So the spaces between the atoms of the liquid is greater than the spaces between the atoms of the solids. So the particles are further apart with weaker forces of the attraction between them and are arranged randomly, has no fixed shape. So the shape of the liquid is not fixed. Whatever the shape of the container in which it will be put, so the liquid will adapt the same shape. They possesses even enough kinetic energy to vibrate and move past each other. Now we are going to read the gas. The gas molecules are well spaced out. So the spaces between the molecules of the gases is greater than the liquid and solid. Occupying whatever space is available to them, the forces of the attraction between the gas particles are very weak. So this is another very important point to be remembered, that the forces of the attraction between the gas particles are very weak. The particles possesses higher kinetic energy to move continuously and randomly at high speed and collide with each other and the surface of the container and put pressure. Here is another question. The statement of the question of the A part is, by describing the movement of molecules, explain what is meant by diffusion. And here is the answer of the diffusion. Diffusion is the continuous random movement of the molecules from a region of the higher concentration of the particles to a region of the lower concentration until both regions are of equal concentration. So the point to be remembered is, this is the continuous random movement of the particles from a region of the higher concentration to a region of the lower concentration until both regions are of the equal concentration. The statement of the B part is, the diagram below shows an apparatus for measuring the rates of the diffusion of the gases. So this is the apparatus which is used for finding the rates of the diffusion of the gases. Here you can see the diffusion plug is here. Here will be put the gas whose diffusion rate is to be measured. So gas inside graduated tube, and here is the water in this tube. So the times taken for 100 centimeters cube of some gases at room temperature pressure to diffuse from this apparatus are. And here are some gases. For example, first one is the carbon monoxide. Time per second will be, time in seconds will be 132. So this is the rate of the diffusion of the carbon monoxide. For chlorine gas, 211. For methane gas is 100. Nitrogen gas is question mark. So it will be like a requirement. Oxygen's rate of diffusion is 141. Anyways, the requirement of the first part in the B part is, which gas diffuses fastest. So from the table we can see methane gas is having the lowest time. So it has the fastest rate of the diffusion. But the method to find is, to find the rate of the diffusion is, first we will find the relative molecular mass of all these gases, and the gas with the least relative molecular mass will have the fastest rate of the diffusion, because the gas with the least relative molecular mass will have the least density and will have the maximum rate of the diffusion. And here you can see the answer. CH4 methane, having the relative molecular mass 16, has the lowest relative molecular mass. The statement of the second part is, why does this gas diffuse fastest? So it will diffuse fastest because this is having the minimum relative molecular mass and minimum density. So that's why it has the fastest rate of the diffusion. So here is the answer. It has the lowest density because it is having the minimum relative molecular mass. So that's why it is having the fastest rate of the diffusion. The statement of the third part is, suggest the time that nitrogen would take. So nitrogen's relative molecular mass is 28 as that of the carbon monoxide. So relative molecular mass of the nitrogen and carbon monoxide gas are same. So it will have the same density. So that will so those two gases will have the same rate of the diffusion. So it will take also 132 seconds. So the time taken by the nitrogen gas to diffuse will be 132 seconds. So here is the answer, that is 132 seconds, since nitrogen has the same relative molecular mass as carbon monoxide, that is both having 28. So both gases should have the same density and therefore diffuse at the same rate. The statement of the fourth part is, name a gas which will diffuse faster than any of the gases shown in the table. So in the table we are given carbon monoxide, chlorine, methane, nitrogen and oxygen gases. So hydrogen gas is a gas which will have the fastest rate of diffusion than these gases, because the relative molecular mass of the hydrogen is 2, which is lower than those gases. So hydrogen gas will be a gas which will diffuse faster than any of the gases shown in the table. So here is the answer. Hydrogen gas, since the relative molecular mass of H2 is 2, that's why this will have the lowest density than those gases given in the table. So the rate of the diffusion of the hydrogen gas will be the fastest as compared to those gases. The statement of the C part is, why is this apparatus unsuitable for finding the rate of the diffusion of the ammonia? So look now at the apparatus. So you can see here is water filled in this tube. So ammonia gas is very soluble in water. So the water level will rise up and fill up the whole graduated tube. So that's why this apparatus is unsuitable for finding the rate of the diffusion of the ammonia gas. So here is the answer. Ammonia is very soluble in water. The water level will rise up and fill up the whole graduated tube. So that's why this apparatus is unsuitable for finding the rate of the diffusion of the ammonia gas. Here is another question. The statement of the question number 3A part is, the diagram represents the arrangement of the particles in a solid. So this is the arrangement of the particles in a solid. First part is, describe the movement of the particles in the solid. So here is the answer. The particles in a solid are held closely together in a regular lattice. So this is the point which you have to write down in the paper. So the particles in a solid are held closely together in a regular lattice by strong forces of the attraction. The particles can only vibrate in fixed position. So this is the second point which you have to write down in the paper. The particles can only vibrate in a fixed positions. The statement of the second part is, how does this movement alter as the temperature of the solid is increased. So as the temperature of the solid will be increased, so the particles will gain more energy. They will move more vigorously at higher speeds. So this will be the change. So here is the answer. As the temperature of the solid increases, the particles gain more kinetic energy and vibrate more vigorously at higher speeds. The statement of the third part is, how does this moment alter as the solid melts? So when the temperature of the solid will reach the melting point, the particles will have gained enough kinetic energy to move out of their fixed positions and move past each other. So the regular lattice will be break up and solid melts. Here is the answer. When the temperature reaches the melting point, the particles will have gained enough kinetic energy to overcome the forces of the attraction between them. They can vibrate out from their fixed positions and move past each other. The regular lattice breaks up and the solid melts. The statement of the B part is, samples of the gases carbon dioxide, relative molecular mass is 44, and hydrogen, relative molecular mass is 2, are at the same temperature. Compare the speeds of the molecules in the two gases. So as you can see, the relative molecular mass of the hydrogen is much lesser than the relative molecular mass of the carbon dioxide gas. So hydrogen will have much lower density than that of the carbon dioxide. So hydrogen's rate of speed will be much higher than that of the carbon dioxide gas. So here is the answer. Hydrogen gas is very much lighter than the carbon dioxide. Therefore, the average molecular speed of the hydrogen gas is very much higher. The statement of the C part is, equal masses of the steam and of water contain the same number of the molecules. Explain why the volume of the steam is much greater than that of the water. Because the temperature of the steam is much higher than that of the water. So that's why they will have more kinetic energy and will be spaced out as maximum as possible. So this is the reason the volume of the steam is much greater than that of the water. So here is the answer. Gaseous steam molecules possesses more kinetic energy than water molecules. The forces of attraction between the gas particles are weak, very weak, and the gas molecules are spaced out as far as possible. Thus, the volume of the steam is much greater than that of the water. The statement of the next question is, in both liquids and gases. So concentrate yourself, only liquids and gases are given. So in both liquids and gases, the molecules present are moving. First part is, compare the movements and the spacing between the molecules in a gas with those in a liquid. So here is the answer. The gas molecules are much further apart than in liquid. So the thing is, you have to compare the gas and liquid. So look now, the gas molecules are much further apart than in liquid. So this is the first difference that you have given in the paper. The forces of the attraction between the gas molecules are weaker than that in the liquid. So this is the second point which is given. Both molecules of the gas and liquid move continuously and randomly, but gas molecules move at higher speed. So this is the third point, and generate pressure as they collide with each other and the surface of the container as they possess kinetic energy. So these are the three differences or three comparisons which you have made between the gas and the liquid. The statement of the second part is, how do these movements change as the temperature is increased. So again, in this part also, you will actually compare the liquid with gas molecules regarding the increasing of the temperature. So when the temperature is increased, both liquid and gas molecules gain more kinetic energy and vibrate, rotate, and move more vigorously at higher speeds. When the liquid molecules have gained sufficient kinetic energy, they break away from the attraction forces holding them in the liquid state and escape completely into the vapor state. The gas molecules become even further apart and the gas expands. So this is the actually comparison of the molecules of the liquid and gas regarding the increasing of the temperature. So when the liquid molecules will have gained enough temperature, so their kinetic energy will be increased enough, so they will break away from their positions and move further apart, and they will maybe converted into the vapor states. And as far as the gas state is concerned, so when the temperature will be increased, they will even move further apart. So this is the comparison. The statement of the third part is, how does your answer to second part explain how the rates of the chemical reactions change as the temperature of the reaction mixture is increased? So definitely when the temperature will be increased, the kinetic energy of the molecules will be increased. The rate of the effective collision will be increased. So the rate of the reaction will be increased. Here is the answer. With increased kinetic energy and molecular speeds, the frequency of the effective collisions between the molecules of the reactants increases, resulting in a faster rate of reaction. The statement of another question is, the graph below shows the heating curve for a pure substance. So you can see here is the graph. A part is, what is the melting point of the substance? So the melting point of the substance will be 98 degree C. So here you can see, actually, sorry, it is 80 degrees C, because these are 10 small boxes and one small box will represent 10. So this is the melting point. So this will be 80 degrees C. So the melting point is a point from graph you can see. So there comes a stage when the temperature increased and when the melting point is reached. So the melting point, so the temperature will remain constant for some time, and when all the solid is converted into liquid, then the temperature begins to rise again. So from here you can see, here is the temperature remains constant for a while and then increases again. So it means this is the melting point, that is actually the 80 degrees C. So here is the answer. The melting point is 80 degrees C. Note, when a solid melts into a liquid, a stage is reached when there is no increase in temperature. When all of the solid has changed into a liquid, the temperature begins to increase once more. Note, the boiling point of the substance is 215. So because the same thing will happen at the boiling point also. So this was the explanation. The answer was just this one. The melting point is 80 degrees C. The statement of the B part is, what happens to the temperature while the substance changes state? So when the substance changes state, so actually the solid is going to be converted into liquid. So the temperature will remain constant for a while when the melting point will be reached, and the temperature energy will be used to break the forces of the attraction and the solid. And when all the solid will be converted into liquid, the temperature will begin to rise again. So the temperature which is, so the energy which is used in this process, which is actually using up to break the forces of the attraction of the solid to convert it into liquid, is called the latent heat of fusion. Here is the answer. The temperature remains constant at 80 degrees C until all the substance has melted. A pure substance has a sharp and fixed melting point. Note, the temperature remains constant during the melting as heat applied is used up to break forces of the attraction between the closely packed particles of the substance. The energy needed for this process is called latent heat of fusion. The statement of the C part is explain why this substance cannot be water, because you know the melting point of the pure water is 0 degrees C and boiling point of the pure water is 100 degrees C, whereas the melting point of this substance is 80 degrees C and boiling point you can see from here is 215 degrees C. So this substance cannot be water. So here is the answer. Pure water has a fixed melting point of 0 degrees C and a fixed boiling point of 100 degrees C at 1 atmospheric pressure. Note, the boiling point of a substance is the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure. So this substance cannot be water. The statement of the next question is a student carried out two experiments. In experiment 1, two gas jars were set up as shown. So this is the setup. Here is a gas jar in which air is there, and in the second jar there is bromine gas is there, and here is a glass disc which is separating the two gas jars, and you know the color of the bromine gas is brown. Okay, the requirement of the first part is what was seen when the glass disc was removed. So if the glass disc will be removed, so the bromine molecules will move upward, and after some time the whole color of the gas jars will become the uniform brown color. So here is the answer. Brown bromine gas moves upward into the upper gas jar, and after some time a uniform brown color is seen throughout the both gas jars. The statement of the second part is explain why this change occurred. This change has been occurred because of the diffusion, because when the glass disc will be removed, so the bromine gas molecules from the lower jar and the particles of the air molecules from the upper jar will move continuously and randomly from a region of higher concentration to a region of the lower concentration. They will collide with each other and will be distributed uniformly, and the color of the whole jar will become brown. That will be uniform brown color after some time. This is the result of the diffusion. Here is the answer. The uniform brown mixture is a result of diffusion. When the glass disc separating the two jars is removed, bromine molecules and the constituent gases of the air move randomly from the gas jar where they are of higher concentration to the gas jar which they are of a lower concentration. They collide continuously and randomly until the particles of the both gases are distributed uniformly throughout the whole mixture. So this is the result of the diffusion. The statement of the B part is the experiment was repeated using the brown gas nitrogen dioxide, that is NO2. First part is how would the rate of the change be different from that observed in experiment 1. So the rate of the change will be much faster because the relative molecular mass of the NO2 is 46 and that of the bromine gas is 160. So it means the density of the bromine gas is much higher than that of the nitrogen dioxide. So being the lighter gas, nitrogen dioxide and the oxygen molecules will diffuse faster. So it will take much lesser time. So this will be the change. So here is the answer. A uniform brown gas mixture is obtained within a shorter time than experiment 1. because the density of the nitrogen dioxide is much lesser than the density of the bromine gas. The statement of the second part is, why does this happen? So now you have to give the reason. Because the relative molecular mass of nitrogen dioxide is 46, whereas the relative molecular mass of the bromine gas is 160. So the density of the nitrogen dioxide gas is much lesser than that of the density of the bromine gas. So it will diffuse much faster. So this is the reason that the rate of the diffusion of the second experiment is will take much lesser time. So here is the answer. The rate of the diffusion of a gas depends on its molecular mass. The lighter the molecule, the faster it moves. Thus, nitrogen dioxide would have a faster rate of diffusion than bromine gas as it has a smaller relative molecular mass. The relative molecular mass of NO2 is 46, then bromine gas that is having relative molecular mass of 160. So this is the reason.